My name is Andrea Heverdays, and I teach chemistry at Bearden High School. The handout that accompanies this video can be found at the KCS website under the Student Resources tab. This is Activity 3 for Chemistry, Part 2. If you have issues with this video, here are some helpful hints. And today we're going to be learning about the ideal gas law. We're going to start with a video.
Well, as the weather gets colder, you might notice a tire pressure warning in your car lighting up.
It's common as winter settles in. So why do our tires go flat in cold weather? Good question. Heather Brown explains the science and how to ensure you have a smooth ride.
Excuse me, ma'am. Hey there.
Hey, how you doing?
Hey, so do you mind if we check the pressure in your tires?
Yes, you can.
I'm going to be on TV, ain't I?
I hope so.
I do have a tire gauge if you need a tire gauge, but you're prepared. Okay.
The driver's getting gas. Look at you, right on the dot. So we're looking for 35 PSI at Steve's Auto World in Maple Grove. Okay, yep. You're low. Got an extra service today. Oh, yeah. You're right on, right at 35. Just because the light comes on in our car doesn't mean that our tires are leaking air.
Nope. Yeah, it just means that they fluctuate.
Nate Anderson owns Steve's.
They're kind of like a balloon where when it gets colder, it kind of shrivel up in strength.
That's because cold air is denser. So for every 10-degree drop in the temperature, tires will lose 1 to 2 pounds of pressure. What's the problem with low tire pressure?
You get worse fuel economy. It also wears out your tires faster. You get worse traction on ice.
Can you feel a difference in the ride?
Yes, I can. It rides rougher.
Since 2007, all cars are required to have tire pressure monitoring systems.
I don't check it very often because I have a dummy light.
But if you have an older car, check every few weeks. You could probably use a little air. Okay. You can find the right pressure on the inside of your driver's side door. Your door's telling us 33 PSI. Right. What range do you need to be in?
Usually your tire light gives you about 5 PSI.
And most air pumps have a gauge on them. All right. We're good to go. You thought we just stood around and interviewed people, huh?
Yeah. I was like, what the heck they're doing right there? Thank you.
Yeah. Heather Brown. Full service operation here, huh? WCCO 4 News.
So, in our previous section, Mrs. Kirk explained how pressure, temperature, and volume affect the behavior of gases. But as the video shows, adding more gas to your tires increases their pressure. It also increases their volume. And so we need to measure the amount of gas as another factor that affects gases. So to measure the amount of gas in chemistry, we use moles. The ideal gas law is the mathematical relationship between pressure, volume, temperature, and the number of moles of a gas. It's on your reference sheet and also here. PV equals nRT, where P stands for pressure, V stands for volume, N stands for the number of moles. Again, M is taken by mass. R is our universal gas constant, and T is temperature in Kelvin. The R, that universal gas constant, on your reference sheet has many units, as you can see. I've listed one here as 0.0821 liter atmospheres per mole kelvins. This means that our pressure must be in atmospheres, our volume must be in liters, that our moles must be in moles, and that our temperature must be in Kelvin to match those units of R so that our algebra works out. So let's start with an easy problem. What is the pressure in atmospheres exerted by 0.5 moles of a sample of nitrogen gas in a 10-liter container at 298 Kelvin? So we're going to start with what we're given. We're given the number of moles, that's our N. We're given 10 liters, that's our volume. And we're given 298 Kelvin, that's our temperature. Remember that we're always given R since it's a constant and it's on your reference sheet. Now we know what to solve for, so we have to find pressure. So let's do some math. We're going to start with our formula, PV equals nRT. To solve for pressure, we needed to get that volume divided to the other side of the equation. So when we rearrange it, pressure equals nRT divided by V. Now we just have to plug and chug our numbers. Our moles times our R times our Kelvin temperature divided by our volume gives us a pressure of 1.22 atmospheres. Now let's try a harder one. Sometimes you have to do a lot of conversions before you even start the problem. For example, at what Celsius temperature does a 54 milliliter tank at 745 torr that contains 0.62 grams of nitrogen gas? So this is going to be a lot. We're given in grams. Grams is going to be our amount of substance, but we're going to need to convert that to moles to use our formula correctly. Our volume was given to us as 54 milliliters, but we're going to need to convert that to liters. Our pressure was given to us as 745 torr, but to match our R value, we're going to need to convert that to atmospheres of pressure. And again, we're always given R. This time we're going to be solving for temperature. So to convert is annoying, I know, but here we go. Let's start with volume because it's the easiest. Knowing that we have 54 milliliters of our tank, we can convert those milliliters by dividing by 1,000 or by moving the decimal place over to the left 3 times. When I divide by 1,000, I'm canceling out my units of milliliters to get liters, which will be 0.054 liters of gas. For the pressure, 745 torr needs to get converted to atmospheres. Those conversion factors are again on that reference sheet. If I divide by 760 torr, which equals 1 atmosphere, the torrs will cancel and I'll be left with my atmospheric pressure. Lastly, we need to get moles. Starting with 0.62 grams of nitrogen gas, I need to divide by its molar mass to get the moles. Nitrogen weighs 14 on the periodic table, but being a diatomic molecule, 14 plus 14 makes nitrogen weigh 28 grams per mole. The grams will then cancel, and I will then have my moles of gas. Using these values, I will then use my PV equals nRT equation, and I need to rearrange it to solve for temperature. To get temperature alone, I'm going to divide by N and R to the other side of the equation. So now my equation is pressure times volume divided by the number of moles times the universal gas constant. Now we just plug in the numbers that we just finished converting. My pressure in atmospheres times my volume in liters divided by my moles times my R value. This gives me 29 Kelvin. However, the question asked for the temperature in Celsius. So to go back to Celsius, just subtract 273 to get negative 244 degrees Celsius. The ideal gas law can also just be asked to find the mass of a gas. When finding mass, you have to remember that mass is an amount, and we can get it from the ideal gas law by solving for N. So in this question, it says what mass of chlorine in grams contained in a 10-liter tank at 27 degrees Celsius and 200 kilopascals of pressure. So we're going to start with what we're given. We're given a pressure in kilopascals, we're given a volume of 10 liters, and we're given a temperature of 27 degrees Celsius. And remember, for every degree C, add 273. That will give us our Kelvin temperature. Our R is constant. And then N is what we need to solve for. However, we're going to need to convert it to mass at the end. So instead of converting this time, let's just change our R value. Again, there's 2 R values on your reference sheet. One in atmospheres of pressure and the other one in kilopascals of pressure. So if we start with our formula, PV equals nRT, this time solving for moles, we need to divide by R and T on both sides to get N by itself. This rearranges our equation to where pressure times volume is divided by R times T. Now we're going to plug in our values. This time we're going to keep our kilopascal pressure as 200 times our volume of 10 liters divided by a different R, 8.31. That value represents the kilopascal pressure, and then times our Kelvin temperature gives us our number of moles. Then we need to convert those moles to mass. To do that, we'll multiply by the molar mass of chlorine gas, where that chlorine is Cl2. Chlorine weighs 35.5 grams per mole, but I need 2 of them, so that's 71 grams per mole. When my moles cancel, I am now left with my answer of 0.57 grams of chlorine. Now you try. Thanks for watching.